Okay.
All right, so. All set.
Welcome, warm and friendly, and sometimes a lot of fun. Rotary Club of Westwood Village. Now, I have been advised by our club, and what do you call them? Angelist? What's somebody who's in the religious side of things? Our club conscience, Diane Good.
Yes.
That our technical name is the Rotary Club of Westwood Village. So you're going to see me trying to use that more and more instead of the Westwood Village Rotary Club. Okay. So, please put your phones on silent and make sure that they are in,
I'm calling yours to double check.
right here.
You found it over here.
I know. I thought I left it in the
I
car.
was gonna turn it on.
I know I had to borrow Bob Simon's watch. Okay, Dr. Prairie, can you lead us in the Pledge of Allegiance?
Right here.
Allegiance to the flag of the United States of America and to the republic for which it stands, a nation under God, indivisible, with liberty and justice for all. Thought for the day, Reverend Chris Gaynor.
Reverend?
Yeah.
Oh, your face.
Let's bow our heads. Good and gracious God, we come before you today, united with all who give you their thanks and praise. Fill us with gratitude for your many blessings, both physical and spiritual. We thank you in particular this day for the gift of food and family. Bless this food, Lord, that it may nourish our bodies. Bless our family, especially those who can't be with us today. Thank you.
Very good. Thank you, Chris. Okay. And our song for the day, Maestro.
Please stand for the song. I thought we'd pick an old favorite that most people know, The Happy Wanderer. And I'll put on the hat I wear when I wander, which is frequent. Okay, let's give it a shot. I love to go a-wandering along the mountain track. And as I go, I love to sing my knapsack on my back. Valderie, Valdera, Valderie, Valdera, ha 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 ha. Valderie, Valdera, my knapsack on my back. Thank you, thank you, thank you.
Please remain standing. Please remain standing. Everybody remain standing for a minute. Now, you may sit down if you are a guest of a Rotarian. And you may, no, Jim Meyer, you're not a guest of a Rotarian. You may sit down if you are not a Rotarian. I just want my Rotarians standing up. All right, Rotarians, you may sit down if you're wearing a club pin or a club logo. Let's see who's still standing. Nancy McCready. Yeah, yours is fine. All right. Nancy? No, you're not a Rotary member yet, Gary. Nancy, come on up and get your club pin. And Janet, please note for our treasurer, Nancy is fined $5. Oh, wait. $4.68 for the pin plus shipping and tax.
Thank you.
All right, thank you. All right. I want to welcome our members on Zoom today. We've got past President Michael Newman, past President Chris Bradford, Carol Rosenstein, Music Men's Minds, and past President Marcia Hunt. Marcia, are you local? Are you in Uganda? Are you in Turkey? Are you in Arkansas?
I'm in Arkansas.
Where?
In Arkansas.
Ah, we're cousins, marry cousins. Okay. All right. Okay. I want to thank everybody that volunteered to get us going this morning, including our greeter, Janet Schwartz, our windmill rider, Steve Day, Thought for the Day, Chris Gaynor, Pledge of Allegiance, and of course, our song maestro. Okay, visiting Rotarians. We have any visiting Rotarians, particularly from Reno? Kurt? Eaton Klein Hill. I flew up to Reno to see two very close friends. The best man at my wedding and Kurt Smith. And when Kurt didn't show up at the Reno airport, I called and his wife answered and says, Kurt's in the shower. Okay. So we got our lines confused. But another time, Kurt, I want to go to your Rotary Club meeting someday. So I called my best man and I said, Lee, you're on. Come and get me. Yeah, is that what it was? My email? All right. My bad. Okay. Guests of Rotarians. So let's start at this table because I know we have a lot of guests. Anybody here?
No.
No. Okay. Gary and Kevin, please stand. Gary Rubin is a prospective member attending for his second meeting. Kevin Zavare, is that close enough? Okay, is a friend of mine. He's a client. We have two of his condos up for sale right now, and he's a lot of fun. He would fit in here very nicely. He and I go to battle with these damn HOAs on an hourly basis, and we have a lot of fun with it. So welcome. Okay, I'll introduce our guest speaker in a few minutes. Over at this table, Lisa and Lucy. Phil, would you like to introduce your wife? But she's more than just your wife. She has royalty. Can you explain her position in Westwood? Mm-hmm.
We got from the east of the village down to, I think it's a 10-month boulevard up to UCLA and then up to like up Beverly Glen. And we discussed issues as well, building projects and bike lanes and bus lanes, anything that's going to be impact the area.
Thank you.
She's present at that.
Thank you. Lucy Tsang is also a prospective member, a former Rotarian. And Lucy, you are the director of the what? Okay, welcome. Welcome. Thank you, Lucy. All right. PE, Bob Simon. Whoop, wait. I'm sorry? Oh, she's a member. Eleanor, yeah. Also, my daughter's pediatrician many years ago. Down butt takes this is the next slide.
Yeah. So you can see my coach told me to do lunges to stay in shape. That'd be a big step forward. And from a quote from the 14th Dalai Lama. The purpose of life is to be happy. Finally, I wanted to offer you a commentary on Italian men's fashion. This is an image from the magazine of 4 rotoractors in Italy. I want you to focus your attention on the guy. Bedhead hair, not combed, no tie, no belt, no socks, and short pants to boot. So that's what I have today. I don't know, does that look like you, Ben?
No, but it's me, no.
All right. You know, I love special events, anniversaries and so forth. And today I would like, Jim Meyer, would you please stand up? And I would like all of us to sing happy birthday to Jim Meyer. Happy birthday to you. Happy birthday to you.
January 7th. I heard that video.
Jim, happy birthday. And from your Rotary Club, all health and wealth and happy wishes for you and your wife.
So by the way, next year,
Yeah.
we're going to celebrate his 90th.
In a few months, Ben, we've got a member who's going to turn 100.
What's that?
Terry White Sr.
Oh,
Yeah.
he,
Well, I'm relying on his son to bring him in. Okay. I need that white thing on my desk there and the button. You know, there were a lot of raised eyebrows at the DG visit when I pointed out in my cover letter that this club, all in giving, has given more over its lifetime than any other club in this. John, I can't find John. He's too nice a guy, Ben, you know. That this club has given more in its existence than any club in our district. And that includes Beverly Hills, Manhattan, Santa Monica, LA5, which I think has 10 years on us in terms of when they were chartered. But so much of that giving is the hard work done by our foundation shares. And our foundation chair, Steve Day, has been at it for about 200 years as the club's foundation chair. Has done a fabulous job. I think, if I'm not mistaken, we just gave over $9,000 just for the tickets to the, we did. And anyway, they never tell you who wins, so I don't think anybody ever wins. Oh, you did? Okay. All right. So for the month of November, I wanted to announce a Rotarian of the Month. And for the month of November, I am making that Rotarian of the Month Steve Day. Steve. Now, how many of you know that Steve is a fanatic on wood puzzles? Okay, little known fact. Well, I got Steve Day a Dodger wood puzzle.
Oh my gosh.
That's not for you, it's for Connor. Cooper.
Oh,
And then your pin.
oh, my pin. Okay. Okay. Wonderful. Thank you so much, Mark.
Thank you.
Thank
And
you.
congratulations. Thank you very much.
Okay. Thank you.
All right. Okay, next. Past President Chris Gaynor, you want to talk about the nominating committee? Just make your formal announcement on. Okay, all right. Steve Day.
Done the last few years. But we're also gonna participate in the LAPD toy drive. Great news so far. I've got a commitment from several members to make donations, and suggestions are that for those of you participating in tonight's shopping spree at the Salvation Army, buy your toys tonight and give them to me tonight. For those of you board members who are coming to our house Monday night for our board meeting, great for Monday night. Yeah. And for the rest of you, bring your toys next Thursday, the 11th, and or the last day, last week of the month, which is December 18th. Bring that toy and bring toys to that too, and that is our holiday party, I believe. So again, I thank you, and I thank those from my spirit who have already donated toys. Thank you very much. We're well on our way. We've already collected 6 toys. So I thank everyone who has donated toys already and will coming up. But anyway, 2 flyers, one from Chip and one from the LAPD. So let's make it a really great year.
Sorry. Is there?
2 toys.
Okay.
2 toys would be great. 4 toys would be great. More than that, great too. But if it's just 1 toy, that's fine. So again, thank you. Thank you.
All right, thank you, Steve. All right.
No, toy would be fine. I mean, 50.
Okay. Tonight is our shopping spree. I need tonight is our annual shopping spree. If you have not volunteered for it, there's still time. Diane still needs volunteers for it. But it's 5 o'clock at the Transition Village. You'll get coupled up with a child. You get to take them in a bus with all the rest of us. We have dinner with them. We learn about their lives, about their siblings, and then we go shopping. I'm not sure this year if it's going to be Tiffany's or somewhere on Rodeo for the family shopping. I just want to see if anybody's listening. Bill Rowan. Okay, can we hold down the chatter, please? Thank you. Yeah, right. Okay, Saturday, December 6th, holiday concert, Music Men's Minds at the Brentwood Presbyterian Church, and Carol needs volunteers, if anybody can volunteer. And Saturday, the 13th, Music Men's Salon, the final concert at the library. Now, yes, Ed. You're singing there. Well, then at the which one? At the library. At Music Men's Minds. Okay. Don't you have a nephew singing there also or something? A nephew? A grandson? Ah, okay. Wonderful. All right. This week in history, December 5th, 1955, Rosa Parks, okay, and got arrested. December 2nd, 1927, the Ford Model A debuted, replacing the Model T. December 3rd, 1818, Illinois became the 21st state. Evanston. Okay. December 4th, 1783. December 5th, 1901, Walt Disney was born. December 6th, 1884. I found this very interesting. It took them 36 years to finish the Washington Monument. Wow. No, this is 1884.
That would be quick.
No, it's completed. You're right. The Civil War intervened. And December 7th, 1941, okay, the United States was attacked at Pearl Harbor. And I am proud to say I had an uncle who was there that day and lived through it. Kurt, were they really? But living there or in the military? Wow.
I'll give you a story of that. Was the quarterback UH football game in tonight. He never got his letter because of Pearl Harbor until about 50 years later.
Wow. Interesting, Terry. Okay. So in 2 meetings from now, December the 18th, we're going to have a regular meeting and a gift exchange. And I have put together some rules for the gift exchange and a few little tweaks. And I've got Ben and Bob and Diane giving me the green light. I always want to know if I'm stepping over the line. I came really close on this one.
Yeah, you sure know.
Yeah, I did. Okay, these are the rules. These will be distributed. These are the rules of the holiday gift exchange on December the 18th. Everyone should bring a gift. It can be a white elephant gift or a real one. Your decision, $25 maximum value. Each gift must be wrapped. Barbara, my assistant, will be at the front door to wrap them in rotary shopping bags. Okay? Though, we'll bring them wrapped anyway. This is a double wrap. Those Rotarians who do not bring a gift can let this sit out, or they can pay a $25 fine, and the club will give them a gift. Okay?
So isn't mute.
Whose phone was that?
No, it's on the screen.
Oh. Wow, who was it on the screen?
Spread.
Ah.
Now tell who's to mute is.
Chris Bradford, please mute your mic. Each entrant will be able to blind pick a number from a bowl. Spouses, friends, acquaintances, and significant others are all welcome. You can even bring people you don't like just to get even. Okay? I will allow each person to walk up to the table, the gift table, and choose a gift in order of your pick number. After a person chooses a gift from the gift table, they must return to their table and unwrap the gift for all of us to see. Each person as a gift, as a number is called, may choose to either pick a gift off the table or grab somebody else's gift that's already been chosen and unwrapped. If someone loses their gift, they immediately are allowed to choose a new wrapped gift from the gift table or to grab an unwrapped gift in somebody's possession, with the exception of the person who just grabbed theirs. When a gift loser finally chooses a gift from the gift table, the sequence continues from the last number called. When the final number is called and the final gift chosen from the gift table, the senior member in Rotary membership at each table can make an exchange with anybody at their table unchallenged. The following gifts will be deemed un-Rotarian, worthy of membership in a Lions or Kiwanis Club, and the owner will be fined. These are not allowed. Any gift of hair combs to Tom Barron. Okay? A gift certificate for public speaking to Sergeant at Arms Jim Crane. A regular tie for John O'Keefe. Do you own a regular tie? Just bow ties or just?
Okay.
Okay.
A bow tie, okay.
For you it is, not for anybody else here.
Oh, no, I like them. Tie.
No gifts allowed as a bow tie for Ed Gall. Okay? No gift certificates to Randy's Donuts for past President Michael Newman. Sorry, Michael. No gift certificates to Baskin Robbins for the club president. No gift certificates to the Big and Tall Men's Store in Beverly Hills for Bill Rowan. Mine or me, yeah. Oh, my favorite. No Rotarian of the Year pins for Paul Aslan. I know that's bad. It's really bad. No lessons in cartwheels for prospective member Vanessa. Okay. No CDs of the song Short People, sung by Randy Newman for either Dave Stover or Janet Schwartz. And no gift baskets of hair products that will ship to Gordon Fell. I know. I stepped over the line, I know. I don't like these rules. Talk to Bob Simon next year as president. He'll make his own rules up. Okay, with all of that aside, yeah, go ahead.
It's number one.
Yeah.
Go and get it, at any time, at any.
No, the one who picks number one gets first shot at that gift table, but there's nobody else that has the gift that they,
No, but I thought they could steal anytime they.
there's nobody to steal. They're number one.
Yeah, I thought they
No.
could steal at the end.
No,
That's not your rules.
that's not my rules. The only one that can steal at the very end with unchallenged will be whoever is senior in Rotary membership at each table.
I'll say it once.
Okay, Rotarians, I want you to join me in welcoming a good friend of mine and a fascinating speaker. Really kind of an amazing, you are really going to enjoy this. He and I have been back and forth on the emails. It's pretty incredible what this guy writes about. I can't even pronounce it, let alone say it. But Rotarians, join me in welcoming Dr. Matt Malkin from UCLA. Matt?
Well, you gotta start with a good entrance. It's all downhill from here. Thank you so much, Mark. All the generosity. Rotarians are wonderful out. Great to be able to spend the time in fellowship. When Mark kindly invited me, said, well, we want to hear something new, and don't shy away from the big picture, the big questions. And, I haven't really talked about that before, but I know that we have a very sharp and sophisticated group here. So I thought I'd better give this a try. It's impossible to talk about astronomy today without talking about the absolute revolution that's happening. We're right in it right now. So happy to be participating and be around for this. It's an incredible privilege. And of course, it's a privilege that everyone in this room is paid for, by the way. There is one of my final looks at the James Webb Space Telescope. It's a little hard to get the scale of this. There's a stand for a person that this is the primary mirror, which is really the business end of the telescope. 23 feet from one side. The other, these are gold-coated mirrors. It's folded up now. And producing this, what I have to say, is probably the biggest technical challenge and the biggest risk that NASA ever took that didn't involve human lives being risked. And it really, a lot of people that I knew in this working for, working for so long, were really scared. There were so many ways that this project could fail during launch and after launch. It was such a high risk. Basically, NASA rolled all the dice on this, and they all came up successfully. It all worked spectacularly well. The whole idea of trying to launch a telescope this big, remember, it's about 7 times the collecting area of the Hubble Space Telescope, which was the most ambitious thing NASA had launched in space before that, and that was a great success. This deployment had more than 300 single-point failures. So if any one of these little latches or springs got jammed, the whole thing was a $10 million piece of space trash. And the launch was perfect. From French Guiana. Thank you for the French delivering that. This was very complicated. This is a picture of Redondo Beach. The telescope has to, as you'll see in a minute, has to be as cold as possible, almost absolute zero. And that means it has to be very far away from the Earth, about 1 million miles, not going to get any Earth light, and it has to be shielded from the sun. To give you a scale here, this is 5 layers of ultra thin sunscreen, sun shield, not sunscreen. And this is about the size of a tennis court here. All of this stuff has to be folded up in an origami, so will fit in the nose of the European Space Agency rocket. And then it has to be deployed in outer space entirely remotely. There's no astronauts going to do repair mission. There's no possibility of that. Now, the amazing thing is everything worked perfectly. This telescope was so ridiculously over-engineered. They were so paranoid, basically, after Hubble, that there are so many fine adjustments and tunings that you can make remotely on this, that the telescope is working better than perfectly. It's really better than spec, which is pretty unheard of in a project of this ambition. So there it is folding up into the nose cone of the rocket there. You get an idea of the scale here. Here's a bunch of text trying to somehow fit it in there. The sunscreen is folded in there. All of this stuff has to fold out. Hundreds of different motions a million miles away from the Earth, and it did. Now, why? Now, the big one. You have to, if you're going to justify spending $10 billion of taxpayers' money, you'd better be trying to answer a really big question. Why do we need a big telescope to do that? There's really no other way to do it. And the reason is, if you want to understand about our universe and particularly how we got here, there's no other way. A big telescope, if you think about it, and here's a little illustration of it, is there's Hubble Space Telescope. Here we are today. Big telescope is a time machine. Maybe you don't think of this because you don't realize that all the light travels quite fast around here, 7 times around the Earth in 1 second. But on the astronomical scale, light is very slow. And so the idea of a big telescope is let's collect as much light as we can from the most distant galaxy or the most distant star that we can find. Why? Because if we're looking very far back in distance to very far away objects, we are not seeing them as they are today. But they're like today. The light took, in this case, billions of years to get there, so we're seeing them as they were in the very distant past, the early days of the universe. That's it. So the time travel is possible, actually, for astronomers in this one sense. We can't, it's not like Jurassic Park, we can't have these dinosaurs running around. We can look back and see what their natural environment was with them living in it. Well before there was any Earth, before the solar system was even designed. Because, as I said, looking back in distance is the same as looking back in time. And so the purpose of the bigger telescope is to look back further in space and time. And so there's a bigger telescope that looks back much, much further than we could ever look before. So I'll give you a few of my, so what did we learn from this? This is a quick summary, but I really want to concentrate on the big surprise to me was we want to find the first galaxies, and it turned out to be very unexpected. Not what we were thinking at all. And I'll see if I can illustrate a few of these examples. Anyway, why was the James Webb Space Telescope sold to discover the birth of galaxies? Why do people want to find when galaxies were formed? Because that really is where we came from. It's our origins. Why is that? I mean, because you can't, without a galaxy, you can't have us. Because you can't have us without a planet. We can't imagine any life without actually an Earth, a terrestrial planet. Well, you actually cannot have a terrestrial planet without forming a star first. Well, you cannot form a star unless you have a large accumulation of gas to make the star, which is a galaxy. So the question was, NASA, we're going to find the birth of galaxies, but what they really said is we're going to find the conditions that made it possible for us to exist. And I remember this very distinctly when we were thinking about the Earth version. Decades, and people were not very optimistic. You know, the birth of galaxies is too far away, too faint, this telescope won't be able to see it. We had a meeting and we took little bets. I think this was over a few French bottles of wine. And most of the experts at the table had pretty modest expectations for what the telescope would do. I was the most optimistic and ambitious person in the entire group. Even I was too conservative, not optimistic enough for what actually happened. So people figured, well, maybe we'll be able to find some galaxies, young ones, maybe not the first ones, when the universe was 8 times smaller than it is now, which is pretty impressive. That was a long time ago, because it's been expanding over billions of years. I thought maybe we could go back beyond that. Incredible. Nobody expected this. Nobody predicted. We're now confirming. This is not just a speculative suggestion of the galaxies. We're getting positive proof, positive confirmation of galaxies where you're viewing the universe when it was maybe 5% the size it is now. So I can convert that into time. We're getting pretty close back to the beginning of our universe, and pretty close to the Big Bang. I would say only a few 100 million years after the Big Bang started this entire universe. And you might be thinking, well, 100 million years by human standards, terrestrial standards, that's a fairly long time. But in the time scale of things on the universe, we're now in a 13, almost 14 billion year old universe. That is almost the twinkling of an eye. And it is shocking how the universe managed to form, do all the things it had to form galaxies like the Milky Way, presumably. We can't look back in time to see the Milky Way, but we're looking at galaxies which are going to turn into the Milky Way in the future. And nobody thought that they could do it as fast as apparently the universe has figured out how to do it. So now here's the fun part. The deep questions here. So this might be a little scary, but bear with me a little bit. I'm going to go right back to the beginning now and say time t equals 0 to trace how we got here. This is the big question. How did we get here? Well, at time 0, the universe started in an unimaginably hot and dense state, which we call the Big Bang. We can't tell you what really was happening because the laws of physics, as we know them, don't work there. And one of the reasons they don't work is that our two beautiful theories of physics, one is gravitation, explained beautifully by Einstein, looks like the correct theory, and quantum mechanics, the theory of matter on the smallest scales, also beautifully tested theory, are incompatible with each other and they've never been connected. Einstein tried for the last part of his life, gave up, and discussed a lot of other very smart people that still failed to do this. In fact, in the beginning, we don't even really have a proper working definition of what time is. The distortions of it are so large, you can't even really say what event happened before and after. You can't get a sequence. So I'm going to dodge that question, which reminds me a little bit of St. Augustine, who was discussing the creation of the universe, which actually sounds a little bit like what I'm describing here. One rather smart student, I could imagine someone saying, well, Augustine, what was God doing before he created the heavens? Heaven. And as you recall, Augustine was pretty irritated by that question. So he was making hell for people who asked questions. So I can't. But we did, this is amazing to me. We did that answer pretty shortly after the Big Bang. What is this? A billionth of a second afterwards. Yeah, pretty good idea of what was happening. This is amazing. The universe is expanding in a vacuum very rapidly. And there was so much energy. I know it's crazy. There's actually energy in a vacuum. That's been experimentally demonstrated. At these very high temperatures, particles which is what we're all made of, electrons, protons, dark matter particles, all the matter of the universe was literally created out of the vacuum, out of the energy of the expanded Big Bang. You could take that, we have very good evidence that's what happened. We think we understand why. And a little bit later, down to, what is that, 10 to the minus 6, that's 0.0 followed by 36 zeros, 1 of a second. This is a very important point, so you have to get this point.
Don't look at me here.
Not only were the particles that we're made out of, which are rather relatively rare in the universe, but much more mysterious particles, which make up most mass of the universe, but are invisible to us, the dark matter was also formed. And here's the fun part. Now, although everything was very hot and very energetic and very uniform, this is crucial. There were certain regions where the density of matter was a little higher than average. Why would that be? Well, this gets back to quantum mechanics. When you look at something on a very small scale, there's always a fundamental uncertainty about how much matter is there. Normally, we ignore this uncertainty is so microscopic, who cares? But in the very first fraction of a second of the universe, there's subatomic fluctuations in the density led to some parts being a little bit more dense. I'm just talking about 1 part in 100,000. You're just, oh, that sounds the same. 99 or 99,999 density here, 100,000 here, 100,001 there. Who cares that there were these little quantum fluctuations? We care. Because those little fluctuations, which we know have to exist in quantum mechanics, then expanded until today, they created the largest structures in the universe, which we see. And they match, in fact, perfectly with this prediction. Meanwhile, while this expansion is taking place, this has been a little more interesting to us. After about 100 seconds, that's a long time, 3 minutes or so, 2 or 3 minutes, hydrogen and helium are formed throughout the entire universe. That's promising. That's what you need to make stars with, the building blocks. Well, so that's a good start. Of course, we have indirect evidence of all of the things I showed you there. Nobody's going to be directly seeing that. There's just no way to do it. But we still have a long way to go to get to a galaxy like the Milky Way. Well, we have an idea of what the steps are to make a galaxy. You have to start with the dark matter over dense regions. They have more gravity, so everything is expanding very rapidly, but they won't be expanding as fast as the underdense regions. They have a little more gravity, slowing them down. So the overdense regions slow down. They're not expanding that fast. And after I make it a guess here, after some tens of millions of years, they slow down so much that they're no longer expanding at all. The rest of the universe is expanding around them, but these lumps are holding themselves together. What are they going to do? They still have the gravity. They're going to start collapsing. That's very interesting. So they're going to collapse down to something the size of a galaxy or smaller, actually smaller. And I don't know how long that's going to take. Longer than it takes to talk about it. I just put some guesstimates up here. Maybe another 20 million years or something. Now here's the fun part. The dark matter has really done its job, of course. A lot of students ask me, who needs dark matter? Why are you guys worried about what most of the universe is made of anyway? It doesn't do anything for us. Oh, yes, it did. The gravity of the dark matter was essential for pulling together the normal matter that makes us. It didn't have enough gravity to do it by itself. So we owe our very existence to the fact that there was enough dark matter at the Big Bang, and it's still here. As far as we know, it may be streaming through this room right now, undetected and undetected. We know how much there's to be, but we do not know what it's made of at all.
one of the greatest problems in all of, not just astronomy, but all of modern science. And so the extra gravity of these collapsed dark matter clumps draws in, pulls in the normal matter, which can make like hydrogen and helium gas. Pull it together, and now the gas has to cool down. So it has, for a little while, it has to have a low pressure so that gravity can keep pulling it down. It has to condense an enormous amount. You know, from spread over hundreds of thousands of light years, this gas, parts of this gas, need to condense out to something the size of our solar system. That is an enormous compression, condensation. It's going to require some time, and it's going to require some gravity, and it needs the gas to not push back, so it needs to cool off. It needs to have no pressure that's stopping it from collapsing. Until it can make something maybe like our early solar system, which is a spinning disk of gas. It's eventually going to make a star and maybe some planets in a disk. So I have no idea how long that takes really, but I put a guess there with a lot of question marks. That's still not enough though. Now, after the disk of gas is condensed, that was quite a trick. That was quite a feat. The center of the disk has to now get hot enough again and dense enough, how hot? Plus 10 million degrees centigrade, which is there, so that it can begin hydrogen fusion reactions, which convert the hydrogen nuclei into helium. That, of course, is what powers the hydrogen bomb, and it's what powers all the stars, including the sun. So life is absolutely dependent on that reaction. So that is, in a nutshell, all of the steps we require for the first stars to be born. But I don't think we're ever going to have telescopes big enough to see the first star. We need to see aggregations of accumulations of thousands or millions or more of them together, making a galaxy. Then it would have enough light that we can see. Thousands or hundreds of thousands of brand newly formed, newborn stars. That's what I call the birth of the galaxy. And that's going to take some time too. What happens is, after one dark matter clump has collapsed, others are pulled together by their mutual gravity. And so you have little ones collapsing into bigger ones, and then the bigger ones cluster together, making bigger and bigger ones, hierarchical, that is, small objects then accumulate and grow into large objects. And the larger ones are going to be where galaxies are being born. Right. Look at my little timeline here. Isn't that funny? I haven't added it up here, but this looks like it's a lot more than 200 million years just to the minimum basic steps to make a galaxy. How can JWST have found galaxies already formed with lots of stars in them so early on? Nobody predicted it. Nobody really, I would say, fully understands it. People are busy modifying their theories, trying out all kinds of variations of dark matter. We have a little bit of freedom there. We don't really know what it is. And this is going to be big. You know, is there really enough time for the galaxies that James Webb has found? You know, was there enough time for them to form stars? I really don't know. And I think figuring that out, this is what James Webb now needs to work on for the next several years. All right. By the way, I put galaxies in quotes a lot. The first things that James Webb is seeing don't even look like galaxies to me. They look like fragments. Shrapnel. I mean, they're dynamical. They're falling together. They're a galaxy in the process of development. These are tiny. I mean, on this scale, our Milky Way galaxy would be huge. But our Milky Way galaxy is really just an assembly of these hundreds and hundreds of little pieces that form first. That's what must have happened. So want to mention, so where does James Webb actually do this hard work? And I have to stick this in because this is what I'm actually doing. So here's the concept that shouldn't be too scary to people. We want to take the light from these very, very distant little galaxies, pieces of galaxies, newly formed stars. We want to run it through basically a prism which spreads the light out into its component colors. There's the colors there. And you notice, this is the visible colors of light that we can see. And it's a very limited range of wavelengths. The shortest wavelengths are the violet down there. The longest wavelengths that I can see are in the red. But of course, there are lots of other wavelengths that are longer than what I can see, which we never developed the sensitivity to because the sun doesn't really produce much of it. What's the point really having infrared vision? Infrared detectors, of course, were invented for night vision, mostly for military applications. And we astronomers jump on any new technical innovation in the military or whatever that we can get our hands on. James Webb Space Telescope is an infrared telescope, and that is something that is impossible to construct of any size on the ground because it. So now, here's the key. This is a hard concept, but hopefully it won't really shock you. So I'm taking the light, for example, from a hot cloud of hydrogen in a young galaxy being born, and I spread it out into the so-called spectrum. I spread it out into its colors here, and I see an incredibly, uniquely distinctive fingerprint of hydrogen. Draw this in my sleep, recognize this. There's a series, a combination of very distinct bright colors that only hydrogen atoms can produce. And that's it. There's a sort of a blue-green one here, but by far the strongest one is this red one out here. So if you just took a picture, I think that was done. If you just took a picture of a glowing cloud of hydrogen, which is just forming stars right now, it looks pink. This is a famous one. This process is still happening today in our backyard, in our neighborhood. There's the Orion Nebula. This is nearby in our galaxy, the Milky Way. You can almost see that without a telescope. It's a little pinkish there because of the hydrogen. All of that beautiful light is coming from just 4 stars that are right in the center here that were just born recently, just a few million years ago. And this, of course, must have been happening big time when galaxies first formed. Instead of a galaxy today, where you see little Orions, there's an Orion, in these spiral arms, the first galaxies, the whole galaxy was pink. It was all hydrogen. It was turning all of its gas into the first generation of stars. But that's great. But then what happens? Then the universe expands. So that's a picture of a galaxy there. It emits all of this light that you saw, blue and pink and violet and so on. Then that light has to travel across the universe until our telescope detects it. As the photons travel across the expanding universe, they're stretched out and they expand. That's called the redshift. So we won't be able to see the galaxies at all unless we can measure their light at very long wavelengths with an infrared telescope. And that's exactly what the James Webb Space Telescope did. Here's 4 of the infrared instruments designed to spread out the light. These are all underneath the mirror, around the focus. They look at slightly different parts of the sky. This is the one that I concentrated on for the largest single project that was accepted for observing in the first year of James Webb Space Telescope. I'm the principal investigator of that project. Anyway, I think I'll just wrap up with this. This is a ridiculously faint little picture of a little fragment that nobody paid any attention to before. You spread the light out here into its different infrared wavelengths here, and you see some very bright spots. just like I showed you before. Oh my gosh, in fact, that one is the pink light from hydrogen gas. Here's a galaxy full of glowing hot hydrogen gas, except that it's so far away, it's all been redshifted to infrared wavelengths. And there's more, this is what I want to finish with. We also see not just hydrogen, oxygen. This really strong emission here is coming from oxygen bands. So the galaxies, that's not a Big Bang. The galaxies, in this case, almost immediately form stars. That's great, out of hydrogen helium. That's not going to make anything useful for life. Then the first generation of stars die spectacularly in supernova explosions. In the supernova explosions, that produces something the Big Bang can't produce. Carbon, nitrogen, oxygen, all of the heavy elements on which life depends. The iron nuclei in your hemoglobin was definitely produced in an exploding star as it died. There's no other place that came from. There's no question. And so here's a picture of what's left when a supernova explodes. So we've actually seen not the birth of galaxies, but we've seen the death of the first generation of stars producing the heavy elements which are essential for life. We've seen the stars dying so that life at least becomes possible. And I think that's kind of cool. So we still got a long ways to go, but at least we are working on the big questions. And we'll skip all of that. Let me get to my conclusion here, which is people say, well, what is James Webb really going to discover? What are the big discoveries? And I always have the same answer, and I'm always right on this. Look, whenever you have a new telescope that goes so far beyond our current sensitivity, our current limitations of our observations, maybe if by a factor of 100 times better improvement, I can guarantee you that the biggest discoveries that it's going to make as it continues to operate are discovering phenomena and learning about things that the designers and the initial users of the telescope had no idea, because we didn't even know enough to predict what the James Webb telescope would fully reveal to us. And this is happening literally every month with James Webb, and it's going to continue happening. So that's your question. Okay. Questions? How to turn this on? I saw it covered everything.
It's the test.
Professor, thank you for a very interesting talk about a very complicated subject.
It is.
And you have the ability to make it sound like fun. But I just thought
We wouldn't be doing it if it wasn't usually fun. Absolutely. First
thank
of
you
all,
for your astronomy 101, if I could. Class.
so you're asking about astronomy 101?
Yeah, you have a class.
Oh, sure. Actually, since you asked this, and that's a fun question. UCLA students, like many college students, are required, even if they're not majoring in science, to take a general education course in science. And a lot of them take a course I'm teaching now, which is basically Astronomy 101, Introduction to the Universe. And so, of course, we cover a lot of these things. Actually, pretty much at about the same level that you guys are exposed to. I put a lot of lectures that were recorded from that class with some editing on YouTube. And some of them, it varies in quality. Some of them maybe not so well organized, but they have nice slides, illustrations, and I think you could get a pretty good feel. You don't have to pay any money for it. You don't have to pay for your tuition. Yeah. So thank you for asking.
Any other questions? Christine,
What is the name of the YouTube channel?
The name of the
Channel on YouTube with the
The
lecture.
YouTube channel? Oh, and if you just search for it, you have to have a name, so I just said Dr. Dr. Matt and AT&T Malkin. You just go Dr. P.R. Matt Malkin, YouTube, video, astronomy. Then you'll see a bunch of videos. There's a playlist. The one that would be most interesting to you all would be astronomy 4. I mean, there's the physics lecture and things like that. But the ones about the Big Bang and cosmology, I think are reasonably accessible. And of course, it takes a bit more than what you can do in 35 minutes. But if you have the time, give it a shot. And please let me know what you think. If there's things that could be improved or clarified, which I bet there are, let me know.
All right, Dr. Malkin, thank you so much. Thank you.
Thank you.
Hold on, Matt. Matt, on behalf of the club,
All right.
I present to you a book on Westwood and a gift from the club for your time.
Oh my gosh, sure, it was beautiful.
We were running back on emails back and forth, all of them.
Mark really worked hard on this, and I appreciate it so much.
So you could
I
laugh
would have tried this if it wasn't for him. So I hate to encourage you.
All right. Next week, our club speaker will be Melanie Mason, who I've known since she was born. Melanie is the senior journalist for Politico and covering the state of California. And the state of California, which surpassed Japan last year as the 4th largest GDP in the world. A lot going on here, including a governor who intends to run for president. So I hope you'll join us next week. That being said, any other questions? Okay, we are adjourned. Thank you very much.
I don't know if you got to,
I'm sorry, what?
more of
Oh, okay.
now it's a bit.